The automotive industry is undergoing historic change. Paling in comparison to the disruption of the previous decades, today's changes are more sweeping, deeper, and permanent. And the new capabilities we are seeing in today's cars are starting to transform the entire driving experience. But it goes far beyond that. Business models are being transformed. Production models are being reimagined. And artificial intelligence is transforming the manufacturing process from research and design to project management and business support functions. Vehicle to everything, or V2X, and the vision of the fully automated vehicle is driving it all. While autonomous vehicles that perform all driving functions under all conditions is more than a few miles down the road, today's rapidly evolving advanced driver assistance systems are progressively shortening the distance. Rest assured, the autonomous vehicle will arrive. In fact, the industry is already on its way to achieving the critical milestones required to make it happen. Camera system technology is seeing explosive growth as a key enabler of today's ADAS systems. Since backup cameras became required on all new vehicles in 2018, we've seen the technology advance to forward cameras and now surround view applications. Going beyond object detection, the industry is moving rapidly to adopt multi-camera systems and AI-based processing methods to create 360-degree hemispheric views of the vehicle and its surroundings. Xilinx has emerged as a leader in automotive vision technology. The silicon and IP solutions such as hardware acceleration, image warping, distortion correction, perspective projection for natural-looking images, and the stitching of multiple video frames. Combined with application software, this creates a natural-looking high-definition image of the vehicle's surroundings in 3D. We're starting to hear a lot more about 4D imaging radar, the next generation of sensor processing and control. Seen by many as the only viable path to system-level automation, 4D radar brings higher resolution to the range, azimuth, elevation, and Doppler dimensions. 4D imaging radar is capable of providing a dense 4D point cloud that can enable object detection, classification, and tracking. Data streams from multiple channels are processed in parallel, which demands hardware acceleration with independent pipeline data paths. This is where Xilinx plays a critical role. Its SoCs and FPGAs work as co-processors to execute all data compression, pre-processing, and distribution. Its Versal solution was the industry's first adaptive compute acceleration platform. By using Xylon IP cores and high-speed serial links, up to 12 video cameras can interface easily with Xilinx FPGA and SoC-based video and vision processors. LiDAR addresses the biggest roadblock to the autonomous vehicle. It detects everything to an extreme level of detail. Considering its processing requirements, LiDAR's forensic view of the world may seem like a luxury to the current generation of ADAS solutions. But we could be looking at a different reality in just a few years. As the LiDAR market has grown, the adaptability of Xilinx's software and hardware reprogrammable solutions have become the gold standard for meeting the evolving system requirements of LiDAR applications. Today, their portfolio of advanced SoCs, MPSoCs, RFSoCs, and FPGAs have become the go-to system platforms for many of today's LiDAR application leaders. Thanks to the configurable I/O structure of Xilinx solutions, they are perfectly suited for the emerging world of V2X and any-to-any connectivity. The parallel logic enables true parallel processing chains to be implemented, accelerating point cloud processing to significantly reduce latency. And the algorithms can be created with high-level synthesis, Vitis and MATLAB without HDL code, combined with Xilinx's industry-leading heterogeneous computing expertise. All of this has led to the industry's smallest, most power-efficient, single-chip solution for LiDAR and other demanding ADAS applications. Intelligent vision systems, radar, and LiDAR each have distinct roles and advantages for the future autonomous vehicle. But to truly replicate, or even surpass, the capabilities of the human driver, many in the automotive value chains are betting on sensor fusion as the best way to address the limitations of any one sensor type. Sensor fusion, new breakthroughs in AI, and a connected infrastructure for V2X will need to develop simultaneously to make automated driving commercially feasible. But if the last decade of AI innovation is any indication, then the fusion across all sensor types will arrive, along with a safer, more enjoyable life in the driver's seat.